Hello everyone, welcome to Tech with Machines. Today is our day 6 of solving data structure and algorithm problems. And our today's problem is merge sorted arrays. Yes, the problem statement says that you are given two sorted arrays of integers, each of size m and n, with one array having extra space to hold the smaller array. Generally, the array 1 is the larger array than array 2. And we have to merge both of the arrays. So one important point to note here is that both are sorted arrays. Second, we have some extra space in the array 1 where we can actually add the array 2 as well to create a new sorted array. So if you see here, we have been given we have been given 4 inputs. So there are 2 arrays and there are the sizes of the 2 arrays as well, whereas the m being the size of the elements which array 1 contains, though its size is equivalent to the size of array 1 and array 2. Here if you see, array 1 is actually having only 3 elements, but the size is 6. Why? Because array 2 also is having 3 elements. So 3 plus 3 is 6. So when we merge both of them, the final sorted array is something like 1, 2, 2, 3, 5, 6, right? And it has 6 elements in it. So we are already been given an extra space in array 1, nums 1. So we basically don't need to use any extra space. So we will basically be doing it in constant space, but we have to do it in linear time. So if you remember, in our previous video, we have used a technique called two-pointer technique. So we are actually going to implement the same technique here. Remember, sorted and two-pointer technique, somewhere you can establish or keep that in your mind that there could be a way, two-pointer technique could be one of the possible ways to solve this problem, right? Now in this case, generally in two-pointer technique, we have seen that either we are starting one pointer at the beginning of the array and the other pointer at the end of the array, or we are starting both pointers together at the same position. Here, because we are given two different arrays, so our one pointer will be pointing to array 1, nums 1, and the other pointer will be pointing to nums 2, which is array 2. So, and because remember we have to create final array sorted, so we are gonna start from the end of the array because that is where we have been given an extra space in nums 1, right? Because if nums 1 is already smaller, like in this case nums 1 is already smaller than nums 2, so we know that nums 2 is gonna come at the end of the nums 1, right? Or even if it was other way around as well, still the adjustments could have been done and would be easier to be done from the end of the array. So our both pointers will start from end of both the arrays. So let's first initialize, or let's do a dry run. So our pointer 1, let's call it pointer 1. And remember, when you are using any variables or any any space, any constant space in your problem statement, remember to use very relatable variable names so that you can then code it properly. While you are doing a dry run, you can correlate it with the code also, where it will become easier. So pointer 1 is pointing to nums 1, and we are being given the partial size of nums 1, which is m. So basically the last index position will be then the m minus 1, which will become basically 2, right, in the first iteration. And pointer 2 will basically be n minus 1, which will also be 2. Now if you see here, at index position 2, in nums 1 I have an element called element as 2, and in nums 2 at the index position 2 I have an element 6. So in both of them, the element at pointer 2 here, which means the nums 1 at pointer 1 is what? That is equivalent to 2, and the nums 2 at pointer 2 is equivalent to 6. So nums 2 at pointer 2 is equal to 6. So that is greater than the nums 1. So which means in our array, basically the 6 is going to come, 6 is going to be replaced. So basically here, let me just put this in the end, and I will put 6 here now because my pointer 2 or nums2 at pointer 2 is greater than the nums1 at pointer 1, right? In this case, which would mean that pointer 2 is going to get decremented and pointer 2 now is going to become 1, whereas pointer 1 remained only 2. So this is our first iteration, right? Now in the second iteration, pointer 1 continues to remain 2 and pointer 2 is 1. Now what is at the pointer 1 now? At the pointer 1 we still have 2. So nums1 at pointer 1, sorry, I typed it at the wrong place. So nums1 at pointer 1 has the value of 2 and nums2 at pointer 2, which is index position 1, has the value 5. So which would mean that still the nums2 is larger or greater than nums1. So which would mean that now I will occupy here the position 5 with 5 as an element, and my pointer 2 will decrement to 0, right? Now in this case also one more thing, we are keeping one more variable which is I, because we need to also track the position where we are placing the final element, right? So that is going to be m plus n minus 1, right? So in this case it was 5 and it got decremented, and in this iteration became 4. So at the fourth position we placed 5. Now still point 2 is greater than equal to 0, so I think we can still iterate. So we will do I3, and in this case pointer 1 is still 2 and pointer 2 is 0. Now if we compare nums1, right, at pointer 1, that is the value 2, and nums2 at pointer 2 is the value 3. So still pointer 2 is larger, the element at the pointer 2 is larger than the pointer 1. So we are going to place now 3 at the index position 3. Now with this, the iteration loop actually is out of bound because pointer 2 goes, now pointer 2 here becomes minus 1, right? So it's out of bound. Now we don't have anything left in nums2 to iterate over, so we will basically be done here in this case. But if let's assume that in nums2 we had one more value, or for that matter there were smaller elements in nums1, so we first will there were larger elements in nums1, so we first will go through nums1 and then we still have elements left in num2, right? It was reverse. It was, let's say here there were 3, 5, 6 and this was 1, 2, 2, and in that case we still would have elements in nums2 because nums2 will not move, pointer 2 in nums2 will not move. In that case we still have to iterate through nums2 and add them to nums1 on their actual positions, right? So this is about how we can do this, and in this case, as you can see, we use 2 pointers, but we still iterated over the length of num1 and num2, right? M plus n. So this is still linear time, and now we are going to code it. So as usual, I have already coded it and I have called the file name as MergeSortedArrays, and the class name is MergeSortedArrays, and I have initialized my inputs, which is nums1, nums2, m and n, right? So we started with pointer 1 and pointer 2 being the last index position of both the arrays, and we also kept a variable which will track the output element's position, and unless both of them are greater than equal to 0, we are iterating and comparing which one is greater. Whatever is greater goes to the last index position, and we iterate till any of them becomes 0. After the iteration completes, if the pointer 2, that means if we have still elements in nums2, we will go through them and put them back into the nums1 at the position I and decrement both of them. So if I run this in this case, which is, let me see, so I'm in the wrong directory, so let me go to the directory day 6 and run it. So Python, and this is merge sorted arrays. So you can see that our both the arrays have been sorted. I would have changed it and made this as 3 5 6 and this as 1 2 2. Then the second iteration, the last iteration, which is p22, will actually be run, and we'll get the same output, as you can see, right? So this is all about merging two sorted arrays. It seems to be a very straightforward problem, but if you are not familiar with how to move your pointers and where to initialize them and how to initialize them, it might become tricky when you are actually coding it. So get yourself well acquainted with two pointer technique, and you will be able to solve all the problems which are somewhere correlated with that technique or a pattern. I hope you liked today's video, and if you did, please smash the subscribe button or give a thumbs up.